There have been a lot of DeLorean owners of late who've been having starter problems. You know, they go and turn the key in the ignition tumbler and the engine doesn't try to start, doesn't even spin. And so some of us old heads have been giving them some diagnosis tips, and based on their responses, it appears that some owners don't actually understand what is going on with the device itself, the actual starter motor. So I've got two starter motors here. This is a Paris Rhone. This is the starter motor that the car would have been built with. And then this is an Eagle Premier starter motor, 3.0 starter motor. And this is what most owners are converting to now. Like Houston doesn't even sell the Paris Rhone anymore. All they sell are Eagle Premier starter motors. But they both work exactly the same way. The only difference is the size of the unit. And I'll show you both. But the way a starter motor works here, a DeLorean starter motor works, you've got two components here. This is the actual starter motor. Okay, this is what spins and then spins the engine. So this is the actual starter motor itself. And then this piece hanging off the side is a solenoid. And the solenoid serves two purposes. The first is to act as an electrical switch. Okay. This is the wire that will actually power the starter motor itself. It's a very large 4 to 2 gauge battery cable. And so there's no way that you're going to be able to attach a big old wire like this to the ignition switch on your steering column. But more than that, when the starter motor is spinning, there's more than 100 amps of juice passing through this wire. So you don't want to put 100 amps where you're turning the key. So what they do is they run a small gauge wire like this. This is actual DeLorean starter circuit wire. And you see that's, 14 to 16 gauge, which is more than small enough to attach to the ignition switch. And then on the starter motor itself, that's where this white with red wire will ultimately end up. This is only going to draw probably less than 10 amps. Okay, it's not going to draw a whole lot of amperage. So you don't have to worry about where you're turning the key. And on DeLorean, they even put an intermediate relay. Other car companies did not. They just went straight from the switch to the solenoid, but DeLorean put an intermediate relay. And what happens, the way this works, this is where your great big cable attaches, this terminal here. And then this terminal, you can see there's already a wire going out to the starter motor itself on that terminal. So these two terminals have to be connected together to make the motor spin. And that's what the solenoid does. This is a big electromagnet. Okay. From the small terminal, it goes to the windings inside the electromagnet. So when it's energized and energizing the windings, it creates a magnetic field that then pulls this shaft that's in the middle of the windings up. It goes dook, like that, pulls the shaft up. And on the end of the shaft is a disc, a metal disc. So when it moves up, that metal disc makes contact between these two terminals and allows electricity to flow from your big battery cable through that metal disc to the motor, and now the motor spins. And when you take 12 volts away from this terminal, it de-energizes the windings, the magnetic field collapses, the shaft falls back down. It has a spring that pushes it back down, and now the contact between these two is broken and the motor stops spinning. So when people are suggesting manually triggering this terminal, what they're saying is just put 12 volts on this terminal. All you need is a small wire to do it, and see if it operates the solenoid and makes the motor spin. Now, the DeLorean starter motor, the solenoid actually serves two functions. Okay. First is as the electrical switch to close the circuit between these two big terminals and pass all the juice through to the motor. The second is this gear here. This is what actually engages the flywheel and spins the engine around. But this gear cannot be in contact with the flywheel all the time, otherwise the engine would be making the starter motor spin. If you've ever had a stuck starter motor, it makes an amazing noise. So this gear has to be able to move in and out. Move out, engage the flywheel. Once the engine starts, it moves back. Now in the bad old days, a device called the Bendix is what it was centrifugally operated. So as the motor spun up, it would kick this gear, the starter motor gear, out to engage the flywheel. Then when you de-energize the motor, the weights would move back in on the Bendix and cause this gear to retract. Now on a DeLorean, there's a metal piece inside here that's attached to the solenoid. So when the shaft moves up, not only does it make contact between these two terminals, but it also grabs that piece like that, which causes the starter gear to flip out and engage the flywheel. Then when you de-energize the solenoid, the shaft retracts, and that piece, that flipper piece, retracts with it, and your starter gear retracts and is no longer in contact with the flywheel. So let me show you how this all works. And while I'm doing that, some owners have been asking questions about when they're manually triggering their starter motor. They've been asking questions about grounding during the testing process. The starter motor is grounded through the mounting bolts that hold it to the bell housing. Okay, this whole outer housing is grounded. Okay, it's one big ground plane. These are all 12 volts. These three terminals I've been showing you are all 12 volts. So when we're testing the starter motor, we're going to continue to use the block ground that it uses in its normal operation. Okay. In fact, you don't want an additional ground, because what you want to see is, does the starter motor operate normally with the grounds that it normally has? And if it does, then you know that you don't have to worry about your engine block ground or anything downstream from the engine block ground to the battery, because the starter motor was spinning with its usual grounds. All you're going to want to do is put 12 volts on this little trigger terminal here. So I'm going to do that right now. I'm going to put 12 volts on this terminal. You're going to hear the solenoid go took. If I had a meter between these two, you would hear, the meter beep, or I'd have continuity between these two terminals. They do not currently have continuity, but once I energize the solenoid and the metal disc moves up, these would be connected. And you're also going to see the gear jump out. And then when I de-energize it, you'll see the gear jump back, the metal disc will move down, and the contact will be broken between those two. There's the gear jumped out. So that is what happens when you turn the key in the ignition tumbler. And let me show you on the Paris Rhone. Like I said, both of these starter motors operate identically. This is an old Paris Rhone. Once again, it's grounded. The entire housing is grounded. So when I trigger the solenoid, this is the Paris Rhone solenoid, it operates exactly the same way. You're going to see its gear jump out. So it doesn't matter whether you have an Eagle Premier starter motor or a Paris Rhone, they both operate the same way. And the diagnosis that us old heads are giving you all is try manually putting 12 volts on the trigger for the solenoid. If you put 12 volts on the trigger for the solenoid and the motor spins, the engine itself may start if you have the ignition on, then you know that everything from this point south is working properly. You know your grounds are okay, your engine block ground is okay, you know that your starter motor itself is working properly, you know that there's no problems with the battery cabling, that the problem is from this point back towards the ignition switch. But if you put 12 volts on the solenoid and it doesn't try to spin the starter motor, or it doesn't manually engage the solenoid, then you know there may be a problem with the starter motor itself that needs to be investigated.